Howdy. So today I'm going to go over restoring S3 object store to the S3 object store for a tenant. And we'll start by opening up a provision pod inside of the relevant AMP cluster. And to do that, we will jump over here to some documentation. We're going to be in the dedicated issue tracker repository, which has the name team. And under the runbooks subdirectory connecting to AWS resources. You may have seen this before in other videos, but I'm going to go through it anyway. What you'll need to do is clone the AMP repository. There's a whole environment setup how-to somewhere else that's not covered by this video, but hopefully your environment is already set up. So clone the AMP repository and then CD into it, and then we're going to start here. So this first command is going to sign me into the 1Password command line interface. And then we'll come back here, and the second command is going to set the environment variables for the appropriate AMP cluster. You can get some more details about the various AMP clusters from this block of comment, but because I wrote this, the example is actually the one we need. So I'm just going to copy the example. It'll ask me to sign in twice. That's normal. Okay. What's next? We'll assume a kube control context so that we can access Kubernetes. And then we're going to set the tenant model. If you see here, note for USA gov-cloud models, you will use the commented command instead. So we're going to grab that one. And just to make my life easier, we'll take advantage of tab completion here. So the name of the tenant we're going to is validate. So that is correct. And we can make sure that that's right by just echoing the tenant model. And sure enough, tenant ID validate. This last command will execute a shell inside of a pod running in the AMP cluster. That's called AMP operator access. And then you give it a stage. For this particular process that we're working on, we're going to want the provision stage. I was just looking at my notes there. So we'll just type provision here. This -t 1440 is, or 14400 is a indicator for how long the pod will last. If you divide 1440 by 3600, you get the number of hours. I don't want to do that in my head right now. But yeah, you will want to set this to something long if it's a process that's going to take quite a while, because the pod will terminate itself after this number of seconds, and you wouldn't want that to happen in the middle of your recovery process if it's quite a large one. So this last piece here is going to set the AWS profile that we will be able to access from inside of the pod. And so in our case, we're going to want to use the provision profile, which is what this says right here, provision. So I will go ahead and copy this, and we're going to put that into this new shell. Remember, the shell is inside of the AMP cluster. So now if we say echo $AWS profile, you can see that we have the provision profile set up, which is perfect. That's just what we want. So let's go back to the documentation. And you'll see here, this command we can skip. All this is doing is just saying, look, you can do a thing. But you'll see the next line here is if you're following instructions in the restore from backups runbook, which we technically are, then return to those instructions now. And so that's what we will do. Let's go up to the top of this documentation, and you can see the various ways, various things we can restore, Gitly, RDS, and in our case, object storage. So let's jump down to there. For the purposes of this demo, I'm just going to do restore selected objects. So we will start out by just building up some environment variables, which you may have seen in other processes. Start by giving it the name of the bucket we want, and this is useful to see. In S3, in a tenant, there are there are buckets that are created by Terraform, and uploads is one of them. They mentioned artifacts in the documentation that we were just looking at, and artifacts is one of them, though I don't see it. It's in here somewhere, I promise. There it is. And they are prefixed by the name of the tenant, which in this case is validate. We're going to work off of the validate uploads directory because this is a pretty empty instance, and this is a place where there is some data. So let's use the avatars that were created for the number 2 user. In this case, the number 2 user's name is alertbot. Perfect. And we're going to start by deleting this file. So let's just grab this S3 path. We'll go back over here. We're just going to cause a little havoc. Delete this. Okay, so now we can go check, and that should be gone now. Sure enough, I have left this other file in here, alertbot dummy, because if you delete the last file in a sort of a folder of a bucket, then that folder also disappears, and we don't want that. So we just have this placeholder in here, but you can ignore it otherwise. Okay, let's go back to the documentation, and we're just gonna, as I was saying, we're gonna build up some of these paths. So we'll start with bucket suffixes, which in this case is not artifacts, it's uploads. Tenant ID is going to be figured out from the tenant model that we set earlier. Primary bucket is going to be the tenant ID with the suffix. So if we echo, it should say validate uploads. There you go. Replica bucket is going to be the same thing, except it'll have the word backup in the middle. And we can look real fast just as a demonstration. Not that one, this one. Again, if we look at the buckets, you'll see there's a whole lot of validates and then a whole lot of validate backups. So let's look at what this block does. First of all, we haven't done this yet, but we need to create an objects.txt. That's mentioned up here. And you remember we only deleted the one file. So let's make an objects.txt with that one file in it. I'm going to look at my notes. The objects.txt, this documentation doesn't tell you, but what it should look like is this. So we'll go back to our document or back to our work spot here. And this is actually not support bot, this is alert bot. So we'll say to alert bot. So the actual format for the path is just we're omitting the bucket name. We're just giving the inside of the bucket path with the file name. So what this is going to do is it'll loop over the contents of objects.txt, which in our case is only one, but only one file, but it could be many. And then looking at the primary bucket and the replica bucket, it's going to look and see if there's a delete marker. And if there is a delete marker, it's just going to remove that delete marker, which will return the file back to its previous state. So effectively what we're doing here is we're undeleting files. We're not like restoring them from somewhere else. We're just undeleting them. So let's run this and see what happens. Looks like it did what we wanted, but let's check. And that file is back. So if we go and look at versions here, you can see that there are delete markers in here. This is because I've run this simulation a couple of times. But what happened was the AWS command line interface went in and removed a delete marker, which would have been up here, and that made the file reappear. So this procedure is useful if the file has been deleted, but the bucket and the folders are all still there. So let's simulate another situation. Let's simulate the whole bucket has been removed. Sorry, not the whole bucket, but the whole directory has been removed. So what that's going to look like is if we go up to 2 here, and then we're going to remove both of these files. So start by grabbing both of their S3 URIs. So we'll say AWS S3 RM paste. And then we'll also delete the primary. So remember what I said earlier, if you delete both of the files in a path inside of a bucket, then that path will be removed as well. So now if we go look, this 2 should be missing. Sure enough, it is. So if we take the, just to show a fail case, if we take the objects and we add our other file in that we want, so that would be dummy. And then we try to run this same command that restored earlier. As you can see, that works perfectly, which was not exactly what I thought was going to happen, but apparently that does work. So now we know. We were able to restore both of those files using the removal of the delete marker. So that's great. I didn't actually know that was going to work that way. But another way we could have done this, let's just pretend that the files have been removed in a way that the delete marker, the full file doesn't exist. There is no delete marker to remove. I'm going to simulate that. So in this case, we'll just delete these 2 again. And instead of using the this block for restoring the delete markers, what we're actually going to do is we'll go back to the documentation and we'll pretend like we've lost the whole bucket. So what you can do in that situation is copy the contents of the backup bucket onto the current bucket with this S3 point in time restore. So let's go ahead and do that. What we'll say is, I'm just going to take this whole block. We'll come back into our environment, and there's a couple things that are new here. There's this undercase bucket type, which is not the same as the capital bucket type. Now, I'm not messing with this documentation because it's somebody else's, but I think this could actually just be the capital bucket type. I'm going to go ahead and by hand replace these for the sake of this demo. So it's uploads, and here again is uploads. So what this is going to say is point in time restore. The bucket source is the backup uploads bucket, and the bucket capital B, the bucket destination is the just tenant ID uploads. So it also wants us to give it a point in time. So I'm going to say today, 2024, 08. That's an 8. 16. And then I'll just say zeros. Max workers 1. I don't actually know what this does, and the documentation has it set to 30, but workers probably uses a lot of power, and I don't need a lot of power, so I'm just going to say 1. So what you'll see is it's going to restore those files, but it's going to restore them by copying them over. So if we go and look, we should now have both of those files back. But we don't. It looks like I've got a 2023 and 20, so instead of 2024, so let's fix that. There we go. So now we have restored those 3 files. Let's go look at the actual directory. We'll just refresh this and they should appear. So you'll notice that we actually only got the alert bot. We didn't get back the dummy. That makes sense because of the point in time we asked for was actually 000. So I think that was something like 2 hours ago, and I just made that dummy file a couple of minutes ago. So we did a point in time restore from before that dummy file existed. So it's important to note that time that you give it does matter. In this case, we actually saved ourselves something because that dummy file was never supposed to be there in the first place. Now, there is a support bot dummy 3 file that did get restored because I made that one a couple days ago. And so this timestamp of 2 hours ago did in fact cover that. Okay, so we've now shown the 2 ways you can restore objects, and I think all we have left is cleanup. There's not much cleanup to do here. It's basically just exiting out of the pod that we've created, and then if you want to clean it up ahead of time, you can delete your running pod. And that's it. Thanks so much for watching.